Welcome to our webcast today, Building a Better Data Center with 24 gig SAS. My name is Rick Kutzpol. I'm the president of the SCSI Trade Association. I'm also a product planner within Broadcom. Along with me today, I have Dennis Martin, founder and president of Demartec. He will be covering a good portion of this presentation. And then we also have Bill Martin, who's co-chair of SNIA Technical Council. He's also the chairman of the Insights T10 committee, which is the technical committee that covers SAS, and he's with Samsung Electronics. Bill, do you want to say a few words? Bill, can you hear me?
I'm sorry, I put my phone on mute. Sorry to all of you. So I will start again. This is Bill Martin, and I would, on behalf of the Storage Networking Industry Association, like to also welcome you to this webcast and tell you a little bit about SNIA, who is co-hosting this with the SCSI Trade Association. SNIA is celebrating their 20th year this year, had their 20th anniversary celebration back in September. And SNIA is made up of 160 member companies, and we have 3,500 active contributing members. Those members help to both develop standards as well as to help to market storage within the storage industry. We are in our marketing attempt to be vendor neutral and rather focus on what is going on within the storage industry. And we have 50,000 IT end users and storage professionals worldwide that are part of the community that we reach out to. So with that, I'd like to welcome you from the SNIA point of view and turn it back to Rick.
Thank you, Bill. As I mentioned in the beginning, I am with the SCSI Trade Association. The SCSI Trade Association is also a 20-year-old industry alliance made up of key ecosystem partners promoting everything SCSI. So today we'll be focusing, of course, on SAS, but remember that there are many protocols based on, or many interfaces based on the SCSI protocol. To name a few, right, USB, fiber channel, FireWire, of course, iSCSI, all part of the SCSI environment. The SCSI Trade Association promotes SAS, today's SAS, by a number of different outbound venues. We're visible in trade shows, blogs, white papers, our web presence. And one of our biggest tasks is to host industry plug fests. We partner with the University of New Hampshire at their interoperability lab and host SAS Plug Fest. So to learn more about the SCSI Trade Association, I urge you to go to scsi.org for more information. So what we're going to cover today is I will give a 24 gig SAS update, kind of a snapshot of where we are in the standards, where we are in the whole ecosystem. And then I'm going to touch on kind of the high-level things that are new in 24 gig that should be noted, definitely just the high-level pieces. And then I'll turn it over to Dennis, and he's going to talk about using 24 gig SAS in building as a building block to data center components. So this is the SCSI Trade Association technology roadmap. Today we're in our third generation of SAS with 12 gig. It started at 3 gig in the early 2000s. Today we're in full swing with our 12 gigabit per second SAS. More interestingly, as we look forward, we're looking at 24 gig SAS. And 24 gig SAS can be seen as made up of two basic components.
Rick, are you there?
Was there a question? Okay, then I'll continue on.
Rick, we lost you for a minute or so.
Can you hear me now?
Yes.
Okay.
You stopped off with 24 gig SAS consists of two components.
Oh, I'm sorry. I must have been a glitch. Okay, I'll back up. 24 gig SAS is made up of two basic components, SAS4 and SPL4. SAS4 being the physical layer piece of the specification, and then SPL4 being the protocol layer of the specification. SAS4 has exited its review cycle and it has been forwarded on for publication. SPL4 is in its final review cycle, we call it public review, and is expected to exit public review the beginning of January 2018 to be forwarded on for publishing. So the next step is for a PlugFest. Right now we're targeting our first industry standard PlugFest in conjunction with UNH at the end of 2018 to the beginning of 2019. And we expect production components to be available in the order of 12 to 18 months after that, with then OEM launch, 2 to 3 quarters after that. So the next, I wanted to give you an update on the market projections for enterprise storage. This is recent data from Trend Focus from their long-term forecast, and I've given a snapshot of enterprise media shipments in millions of units, and I've broken it up into a couple pieces. The bottom blue bar is the rotational piece, so this includes a somewhat declining SAS rotational market being predominantly offset by SATA and nearline storage devices. You can see plateauing at about 60 million, just north of 60 million units a year out in 2021. I then take the SSD portion and I've broken it out by interface, and so you can see the progression of SATA and then NVMe coming on, and giving us a pretty even split in 2021. And again, this is Trend Focus's snapshot of the world. There are other pieces of industry data that differ slightly from this, but it gives you a good sense. The key takeaway here is that over 90% of connected devices in the enterprise will be connected via SAS. Because remember, SAS as an infrastructure not only supports SAS hard drives, but it also supports SATA hard drives, SAS SSDs, and SATA SSDs, all very important in the overall enterprise ecosystem. So then I wanted to touch a little bit on 24 gig SAS. So what's new in 24 gig SAS? So what we wanted to accomplish in this technology node is we had a product goal to double the effective bandwidth while maintaining the overall value proposition of SAS, right? SAS has a very rich value proposition over the past 3 generations. And so we wanted to make sure we could deliver backwards compatibility, best-in-class price performance, maintaining that existing reliability and scalability, all critical components to the SAS infrastructure. So to get to the actual physical rate on the wire, we had to pick an encoding scheme, right? Traditionally, SAS through 12 gigabit per second SAS has been based on 8B, 10B encoding, and we've moved to a more efficient encoding scheme at 128, 130. This is in line with most other serial technologies, PCIe's 128, 130, USB's 128, 132. So it's in alignment with other similar technologies. Probably the biggest advancement is the addition of forward error correction. We've added a 20-bit Reed-Solomon forward error correction algorithm to 24 gig SAS. And the goal here is to be able to allow our customers to run their channels with a raw bit error rate on the order of approximately 10 to the minus ninth, while achieving effective bit error rates that are traditional to SAS on the order of 10 to the minus 15th. Right? So what this ultimately means is that 24 gig systems can be created and not leveraging exotic materials, exotic board materials, optics, things like that for traditional within the data center type deployments. So that's going to be a big piece of 24 gig SAS. So based on the encoding scheme that we've chosen, and then the 20-bit of forward error correction, in order to double the effective bandwidth from 12 gig SAS, we ended up with a line rate or a baud rate of 22.5 gig. And Dennis will talk about the comparisons of some of the bandwidths in a minute. Another thing that we've done is we've enhanced our transmitter training algorithm. At 12 gig, we implemented transmitter training based on training on a static pattern at the start of day, and then the SerDes settings were locked. With 24 gig SAS, we're implementing what we call active PHY transmitter adjustment. I call it continuous adaptation, where the PHYs actually train on live data all the time. So in the scenario where there's an environmental change, whether a fan goes down, the power supply has a problem, any environmental changes like that then will be picked up, and the SerDes settings will be continuously changed to make sure that we have the optimum SerDes settings at any given time. Another addition to 24 gig SAS is our fairness enhancements, and this is mainly around deeper topologies, enabling the expander to arbitrate intelligently from one expander to another. Traditionally, there's been no knowledge of traffic on either end of an expander. We're adding that feature this time so that each expander has some idea of the general traffic attributes of its neighboring expander. And then finally, there are a number of features that aren't specific to 24 gig but are aligning with the 24 gig specification. And it's interesting because some of them are performance enhancements geared toward non-volatile storage, solid-state storage, and others are more to optimize around capacity storage. So take the first one, multi-link SAS. Multi-link SAS was conceived in 2009, and this is actually using the wide port technology that's inherent in SAS to talk to end devices, routing multiple SerDes to a specific end device. When it was originally conceived in 6 gig, there was no need for more bandwidth to the drive, but with advances in solid-state storage, that's very different now, and we can actually take advantage of the bandwidth of multiple SerDes to a drive. And again, this is inherent in the SAS technology, just like when an HBA is hooked to an expander. It could be a by 4, it could be a by 8. In this case, multi-link is really probably going to consolidate around a by 2 connection, and we're starting to see drives come out. There's been a recent press release associated with Flash Memory Summit of a multi-link enabled drive, and we're seeing more of them starting to come out. So we're actually quite excited about the move toward optimizing around performance using multi-link. The next one is storage intelligence, and this is a broad bucket. It's kind of a catch-all for solid-state optimizations. These were ratified a number of years ago, but starting to get designed into the infrastructure. These are things to optimize for background garbage collection tasks, to optimize for data transfer, streaming capabilities, things like that, and we refer to them just generically as storage intelligence. Then there's zone block commands, and this is on the other end of the spectrum. This is to optimize around capacity, the capacity play. And specifically, the zone block commands are there to support SMR technology, right? We're seeing drives being consumed by the data center, well in the excess of 12, 14 terabytes per drive, and we're testing drives much larger than that right now. And the one thing that we within SAS had to do is make sure that we're accommodating for that level of connectivity, whether the drives are SAS drives or whether they're SATA drives. It's all taken care of through the SAS infrastructure. So with that, let me turn it over to Dennis, and he's going to go into a little more detail on some of these topics.
Great, thanks, Rick. This is Dennis Martin with Martech. I wanted to give you just a brief overview about who we are and what we do. We are industry analysts with a test lab. We're an ISO 17025 accredited test lab. We run lots of things with servers, networking, and storage. As you see here on the slide, we run every speed of SAS. I've listed 6 and 12. We have some 3 gig also. We run every speed of Ethernet. We're currently running all the way up to 100 gig Ethernet in some of our projects. We run every speed of fiber channel, all the way up to 32 gig. We run NVMe, and when I say NVMe, we run NVMe over fabrics, and that's with RDMA and fiber channel. So we run a little bit of everything. We love to test these things, especially in real-world environments. We set up the systems the way customers set them up, so we install the operating system or the hypervisor. We set up the whole network. We set up the storage. We do all of that, and we run real-world applications such as databases or Hadoop or any other kind of real-world application. We do sometimes run synthetic tests. Sometimes we even get involved in things like regression testing and QA testing, but for the most part, we do real-world setups. We are an EPA-recognized test lab for the Energy Star Data Center Storage Testing Program, and that I'll just briefly talk about that. If you are a product vendor and you sell to the U.S. federal government, you'll have to get an Energy Star certification for products that are in that have a category for that, which now storage does. I might mention that we're the only test lab in the world who is both certified for Energy Star Data Center Storage and for the SNIA Emerald Recognized Tester Program. And you can get more information about us on our test lab page there. I wanted to just point out one free resource we have for open to everybody. This is a vendor-neutral page. It's one of the most popular pages on our website. It's called the Storage Interface Comparison page. And you can find this either by just searching for those words in your favorite search engine. Just type in Storage Interface Comparison, or you can click that link there. We take every storage interface, and you can see the logos at the bottom there in that piece of art there. And we talk about transfer rates, and we get into encoding schemes. For example, Rick mentioned encoding schemes, so we gave you some detail about what those mean exactly and how things are transmitted and what the efficiency rates is for so forth. We talk about the history. We talk about roadmaps of where these things are going. We get into even cabling and connectors. There are no specific vendor products, though. It is just about the technology, so you're welcome to take a look at that. I'll just mention that we're not a product vendor. We don't make any of these things. We don't sell these things, but we use them all in our lab, and we use a little bit of everything. So that's just a nice free resource for you. And one of the things that we have on there, of course, is information about SAS and the roadmaps and so forth. All right, so let's talk a little bit about SAS itself, 24G SAS specifically. If you want to get right down to it, each 24G SAS lane has 19.2 gigabits of bandwidth. When we get to PCIe Gen 4, which is still in the future but coming soon, each lane there gives you 15.8 gigabits. So SAS actually has more lane for lane, more than PCIe Gen 4 can support. So there's plenty of headroom with SAS, and that works on the back end, and we'll talk about that in a little bit. 24G SAS is compatible with the existing SATA as well as 6 gig and 12 gig SAS. This backward compatibility allows you to mix and match. So for example, you can have some older technology mixed in with newer technology, and you can plug and play and everything works. One of the other things about 24G SAS is that, like the previous generations of SAS, it scales to thousands of devices. So you've got built-in support for very small configurations. For example, you might have a server with a few drives in it, or you can go to very large-scale implementations with big storage arrays and lots of drives and lots of connectivity and expanders and all those kinds of things. So there's quite a scale you can go from very small to very large. Let's talk a little bit about a couple of things. Let's talk about dual port and multi-link. And let me explain the difference here. So on the left side, we've got a little diagram here for dual port. So a dual ported device, typically an SSD or a hard drive, has 2 ports on it, and this is in SAS, and this is true for 24 gig SAS as well as the previous generations, 3, 6, and 12 gig. There are 2 ports that can be accessed, and typically these are set up for redundancy purposes, either in active-active configurations or active-passive configurations. So you basically have what's known as an A channel or an A domain and a B domain, and you set these up, and then both of these 2, in this example, I've got some adapters there. You might have 2 adapters, one in each of 2 different servers, accessing the same drive. And as long as the 2 systems are cooperating with each other and arbitrating things properly, you can get 2 different hosts talking to the same device at the same time. And so that's dual port. You can even test this inside the same server, which we've done. Obviously, you need to make sure, be careful you don't step on each other because now they're the same host. But generally speaking, this is 2 hosts, and again, either active-active or active-passive. On the right side, we have something called multi-link, and multi-link SAS, as Rick mentioned, has actually been around for quite a while. And as he mentioned, at least one drive vendor announced a product at Flash Memory Summit earlier this year. This is how you get more bandwidth out of a SAS device. So you'll see in the picture there, I've got an adapter there, and I've got 2 channels going to one device and 2 channels going to another device, and those are what are called the SAS wide ports. And so now you get more bandwidth. For example, in the announcement that was made at Flash Memory Summit, that particular vendor said they can get at least 2 gigabytes per second of sequential read and write, both read and writes, at least that kind of bandwidth out of that device. So this gives you an idea of the kind of bandwidth you can get with multi-link SAS. Now, in this particular configuration, you'll see that there's one host and there are 2 devices, and the host is accessing what effectively means 2 lanes of SAS for each device. So this would be called a 2x2 configuration, 2 lanes going to each of 2 devices. You can certainly do more than this. You can do 2, 3, 4, 8, or more. It just depends on the capabilities of the adapter or the controller and the capabilities of the device and how many ports or how wide of a port they want to put on those devices. You can also mix the 2, and you can do dual port and multi-link if you really want to, and you can have, and I'll show you an example of how that might work on the next slide. So you can have either dual port, or you can have multi-link SAS, or you can have both. And these are all supported today with SAS. Let me give you 2 use cases for SAS, and typically the way these are done. On the left side here, I have a server use case. And so what we have in this server is an HBA, a SAS HBA, or it could be a SAS RAID controller. And then it's talking directly to, in this example, 4 devices. So we've got 4 drives out there. They could be hard drives. They could be SSDs. And what you typically want to do is try to match or balance the bandwidth between the adapter inside and the devices so that you don't have oversubscription. You don't want to put too many devices on there because in case you need to use them all simultaneously, you've got a nice setup there. So this is typically the way servers do it inside of a server. And this could be either just a regular server or this could be part of a hyper-converged infrastructure. This is all inside the device. On the right side, we've got the storage array use case, and this is where you get a little bit more complexity and a little bit more architecting required. Now you've got 2 controllers, and they could be as simple as 2 RAID cards or 2 HBAs, but more likely there's a little more intelligence in there besides that. And then you've got a drive shelf or some kind of JBOD or maybe multiple drive shelves, and you'll notice here that there are 2 connections to that drive shelf. Keeping in mind that all of those devices, if they're SAS, they have dual port. So basically, you've got a fully redundant situation here. You've got 2 controllers. You've got every device has 2 ports on it. Typically, these are going to run off of 2 different power supplies. So you've got fully redundant here in all the cases, and you load this up with lots of drives. And I've got 8 in this picture, but it could be obviously much more than that. Typically, when you do this, you're going to have a lot more things going on. You've got some cache. You've got other things to keep things coherent and accelerate things where needed. So this is a little bit more complex picture, but this is another use case where you use SAS, and 24G SAS will work the same as 12 or 6 gig SAS worked in the same type of architecture. Let's talk about a few other things that are part of SAS. This is true of both 24G SAS and the previous generations of SAS. You do have a hot swap support, and so this is also known as surprise insert removal. This has been with SAS for quite a while. You can take a drive out, you can put it in, the system's powered up, the system knows exactly what to do with it, it can recover from that, it's not really a big deal. This has been going on for quite some time. Another interesting feature, quite useful, is multipath I/O, or known as MPIO. MPIO is implemented in the operating systems, it's implemented in the hypervisors, it's available in a number of operating environments, and this allows you to have multiple paths to the I/O, and the operating system itself will then keep straight, this host path is connected to this drive, and therefore it doesn't mix up the connections and try to lose track and think that there are multiple drives. Think about that storage array example where you have lots of drives in there, and there are multiple paths. The MPIO software sorts all that out so that you don't get more than you should have and you see everything correctly. This is built in with SAS. This works right away. It's inbox in the operating systems. Each one has different flavors. They might have slightly different algorithms, how they use the multipath, but it's all in there. One thing I'll just mention, I've kind of hinted at it already, is, of course, there's broad operating system and hypervisor support for SAS. That was true of 6 gig, it's true of 12 gig, and most of the players are also going in with 24 gig as well, and they're working on that. So that's a nice plug-and-play kind of thing, mix and match as you need to, because it's just going to be in there. Most of the operating systems and hypervisors even go so far as to have inbox drivers, so when you install that operating system or hypervisor, SAS is already there. And then finally, there's the management infrastructure. This refers to both the software and the host management infrastructure, as well as the management of all those devices, and maybe there's some expanders in there, and all of that, downstream management is also, it comes with SAS, and it's designed for, as I said before, large scale. That's all just built into SAS. So those are all just a few features that you get with SAS, and that's true for the previous generations again and for 24 gig. We did a white paper. The SCSI Trade Association asked us to put this paper together talking about the benefits of SAS, and we published that earlier this year. And we go into a little bit more detail on the whole SAS ecosystem, the concepts of expanders and JBODs. We go to, put the slide back, dual-ported drives, MPIO, hot swap, even in the power consumption cabling connectors. So this is a free white paper. It's out there for everybody. You can get it either off of our site, or you can go to the SCSI Trade Association's website and get this paper. It's, again, free for download. And with that, I think, Rick, I'll turn it back to you.
Perfect. Thank you, Dennis. So I encourage everybody to, if you're interested, to click on that link, and you can get a copy of Dennis's white paper. It's actually a very good read, and it's brief, but it's good context. And also, just a note, these slides will be available as an attachment to the webinar when it's over. So other good reference as well. With that, we do have a handful of questions that have come through, and I can moderate those. So I guess let me just start at the top. The first question is, will NVMe eventually eliminate or severely reduce the need for SAS RAID controllers within the next 5 years or so? Interesting question. It's something that is always being looked at and monitored. Frankly, right now we see NVMe playing a very important role in what I would consider tier 0 storage, caching, metadata, very, very high performance applications. And it will start moving into persistent type applications where data protection will have to be addressed. data protection can come in a lot of different forms, and we're seeing disruption just in that realm in general, with data centers doing replication instead of, straight out RAID. But in general, especially for inside the server, right, data protection is going to have to be addressed. And the best way to do it is, for larger deployments is hardware RAID. And NVMe hardware RAID solutions are available today and will become even more important as we move forward. So specifically, SAS RAID controllers, it will impact that, but I think the question is really more, will it affect, the overall ecosystem? And I don't think so. I think largely they're fairly compatible with each other, and serve different purposes. The next question is PCIe SSD in the trend-focused data NVMe? It absolutely is. My nomenclature was just to label it as the specific interface, and it happened to be PCIe. But yeah, you can read that slide as NVMe. It is not. It's not covering up some other type of implementation. It is NVMe. Let's see. So this one's a little bit longer. As SATA is a 6 gig bus speed and its key volume of the enterprise HDDs, how will these fairness enhancements avoid starvation issues, which some system deployments saw in SAS 3 when mixing 12 and 6 gig devices? Right, very interesting question, because right that window is getting larger and larger. Right, as we go to 24 gig, and there's even more and more capacity optimized drives still at 6 gig and not moving from 6 gig. The answer to that is bandwidth aggregation techniques are going to become absolutely imperative, because if you have a 6 gig drive in a large topology in a 24 gig infrastructure, right, without any bandwidth aggregation techniques, that whole link that is established to that drive will be relegated to, it will use rate matching, and it will run at an effective bandwidth of 6 gig. But with bandwidth aggregation, what we can do is buffer at the end devices the data, and then send it across the topology at 24 gig rates. So in these capacity optimized solutions, you might have 96, maybe multiple JBODs of 96 drives out there, all connected via a 24 gig infrastructure. It would rely very heavily on bandwidth aggregation, and then the fairness enhancements would apply to 24 gig traffic as it was defined. So I hope that helps. Okay. The next one, there's a question on multi-link. I mentioned multi-link. There was a product announcement at FMS, and the request is which company. It's public information. Toshiba announced, I don't want to say the product name because I'll probably screw it up, but you can look at Toshiba's website. The press release is on it, and it talks about their multi-link solution that they announced at FMS. Do we foresee other multi-link enabled announcements soon? Announcements, I'm hoping. I can tell you that I am testing another drive as we speak, so I'm assuming some sort of press will come out based on that drive when it comes out, and I don't know exactly when that will be, but we're starting to see definite momentum behind multi-link. The next question is, will 24 gig SAS support 6 gig SATA end devices? Right, we answered that. It absolutely will. One of the product goals of 24 gig SAS was to be backwards compatible 2 generations, and so that includes 6 gig SAS and 6 gig SATA. And like I mentioned, there are enhancements in aligned with 24 gig SAS to enhance 6 gig feature sets. And the good example was around SMR with the ZBC command set. The next one, doesn't NVMe also support hot swap? They're working on it. And it's definitely achievable. It's defined in the specification. It's a challenge for NVMe, not so much from an NVMe perspective, but more from a PCIe perspective. But it's definitely achievable. It will, there are plenty of devices that support it today. The entire ecosystem will be ready very, very soon. So that's absolutely a yes. How do we register for the 24 gig plug fest? When a date is ratified within the SCSI Trade Association, an announcement will go out, and then anybody can sign up on the STAY website. There will be a link to an enrollment form, and all the details will be listed on the SCSI Trade Association website. That was scsi.org. Some online literature presentations list SAS for serial encoding as 128, 150. So that's a good catch. If you include forward error correction, along forward error correction and the encoding, if you look at the total overhead, it is absolutely 128, 150. The native encoding is 128, 130. Then you add 30 bits of forward error correction on top of it, and that's how you get 128, 150. So that's an interesting. So maybe, I don't know, Bill might be able to answer this. Maybe my nomenclature is incorrect. I would consider the native encoding to be 128, 130 plus 20 bits of forward error correction, but maybe the way the industry refers to it as that is the encoding. Bill,
no, I think what you put down is accurate. That it is an encoding of 128, 130. On the wire, you do indeed see the extra 20 bits for the forward error correction, but it's not part of the encoding. And part of why we make the comment that it's a 128B, 130B encoding is the fact that's the actual encoding algorithm that is used by the standard. And the other 20 bits is extra on the wire, and it would probably be more accurate to say, in terms of the online presentations that you've seen, that the 128 bits consumes 150 bits on the wire, but that isn't the encoding scheme.
Perfect. Thank you, Bill. Hey, Dennis, then we have one for you. How could someone submit its products for testing and use in DeMartech labs?
Great, yeah, I'll be happy to answer that. Just give me a call or contact me. I'll just tell you our office phone number is on our website, but I'll tell you what it is. Area code 303-940-7575, or send me some email, and that's dennis@demartech.com.
Okay. Perfect. The next one is, can you speak about NVMe versus SAS 24 gig scale up in the terms of number of drives accommodated and price comparison? So from a drive perspective, right, SAS by definition supports, I don't know, it's like 64K or so. It's some ridiculous number. There are other limitations that get in the way much before that. Most very, very large deployments are on the order of 1,000 drives, maybe 1,500 drives. That's a SAS statement. On NVMe, because of the nature of the transport being PCIe, being memory mapped, it gets very expensive, and expensive is in a memory context to support very many drives. What the limitations are, I'm not really sure, but it's from a usability perspective, it's significantly less. It's it's on the order right now. It's on the order of 24, 32 drives, in contrast to a scaled out SAS system, which exceeding 1,000. Okay. Are there any plans to define new features to optimize low power or optimize low latency in 24 gig SAS protocol? So the 24 gig SAS protocol, I would call SPL4, and that's done, right? Like I mentioned, it's in its review cycle, and we're always careful of we want to make sure we're optimizing for latency, but it will be consistent with existing latencies. So there were no major enhancements to the protocol to optimize for latency. It's always a topic
Rick,
we're always watching. Oh, go ahead.
So Rick, let me jump in here. I think one of the keys with this particular question is the places where we would define new features to optimize or lower latency is probably not exactly in the SAS protocol, but in the SCSI protocol that goes over SAS. At the moment, we are not actively working on anything that is looking at reducing the tail latency in the device. But we would be open to that if there are people that are interested in providing things that would be a protocol at the SCSI layer above the SAS protocol to lower those things like tail latency. That would be something we would be very interested in considering, but we have no active project doing that now.
Good. No, that's good. Thanks, Bill. The next question, back to fairness. Your reply in the last question, does it mean that yes, fairness will fix starvation issues, thus systems can mix 24, 12, and 6 gig in a single system? So, so my comment on bandwidth aggregation, that aside, if you're just talking about mixing and matching, they all can be mixed in a single system. The deeper the system, the more complex the arbitration becomes. And will fairness fix the starvation problem? In a non-bandwidth aggregated large system, no, it won't completely fix it, but it will help with it. It will absolutely help with it. It will give each expander, like I said, more information about its neighboring expander to be able to arbitrate between connections. Right, as a connection becomes open in traditional systems, it would just feed its next connection. And so if you had high-speed devices higher in your topology, it would starve out the deeper pieces of the topology. With this fairness algorithm, now each expander knows about what's waiting on either side, and so issues like that can be addressed. You're still going to, in a system that's 24 gig with 6 gig drives, you're always going to see, some attributes like that unless you're using bandwidth aggregation. The next one is, would there be concerns about designing backplanes to support a mix of 12 and 24 gig drives? No. The 12 gig drives will be backwards compatible. From an SI perspective, once the 24 gig SI concerns have been addressed, then 12 gig should be an easy subset of that. So I'm not expecting any problems mixing 12 and 24 gig drives. Next one, regarding earlier question about lower latency, persistent connections were defined in SPL to reduce latency. Absolutely. Yes, that is a way. Just noted, it does tie up a connection, right? In a persistent. So what's being referred to here is a persistent connection, where a connection can be opened, and it will stay open, so that you don't have the overhead of opening and closing a connection. So yes, if you want to dedicate API to a specific connection, you absolutely can do that, and it will get rid of all the overhead of opening and closing that connection. So good comment. And I think that's it. If there are no more
you've got a couple more that have come in, Rick.
I can't keep up. You guys keep firing questions at me. Let's see. Is there a greater drive count limitation with NVMe versus SAS because of RDMA memory-to-memory mapping, even NVMe over fabrics, which does not use RDMA? I'm gonna defer Dennis or Bill. You wanna?
This is Dennis. I don't know the direct answer, but we'd love to test it. We've done both RDMA and fiber channel for NVMe over fabrics.
This is a good question, let us take this question, and we have a lot of resources at our disposal between the three of us, and we can address this. And I believe the intent is to publish via a blog or a blog-like scenario the responses to any unanswered questions after this particular webinar. Okay. What's the expected cost difference in supporting SAS4 channels compared to SAS3 channels? You will be running faster, but with forward error correction, the intent is not to have to use exotic materials and not use optics, things like that. Will there be a cost increase in connectors and cables? Probably, at the ramp time, they'll be a little more expensive. The intent, I believe, is that we will see, parity as we move out in time in volume production. So if there is a difference between the cost of deploying a SAS4 channel versus a SAS3 channel, I'm not expecting it to be dramatic, like going to optics or going to adding repeaters or anything like that. See, any thoughts on the cost comparison between 24 gig and 12 gig and 24 gig backplanes? That was, same answer to that, right? No, right. The goal is no repeaters. We think with forward error correction, moving to 22.5 gigabaud, that we can achieve very similar channels as we have in 12 gig. So I'm not expecting a significant cost difference. Okay. Did I get them all, guys? I think so.
I think you got them.
The one that we will address is the drive count limitation relative then to NVMe over fabrics. So we will address that one offline. If there's nothing else, thank you for your time. I think this was a good venue for us to talk about what's coming up in SAS, where we are in SAS. I also would like to thank SNIA for hosting us and Bill being our sponsor on this great Bright Talk platform, and look forward to hearing from you soon. Thank you.
Yep, thanks everybody.